All right, let's finish these up. For this one, we have something that's trigonal bipyramidal with a linear shape. So trigonal bipyramidal means there's 5 groups. 5 groups and a linear shape. So that means we're going to have 3 lone pairs, 2 bonds. So let's look at that. Here we can find it up here. All right, we have, this is going to be linear, so ICL2 minus. Okay, now let's look at this and let's think about this shape. These are all going to be equatorial, all 100 degrees and 20 degrees apart, with the chlorines on the top and the bottom. So this is actually a molecule where things are fairly symmetrical. So all of those partial charges are going to cancel each other out. Next one, 4 bonds, no lone pairs. That means the shape and the geometry are the same. Tetrahedral. All right, now where's that one? Where's tetrahedral, tetrahedral? CF4. All right, so that's CF4. Now in CF4, you'll know that the carbon-fluorine bond is quite a polar bond, but all of these are the same, so it's a symmetrical molecule. Those dipoles are going to cancel each other out in 3D space, so this is not a polar molecule. All right, NH3, we found that one. Here it is. We have 3 bonds and 1 lone pair. 3 bonds, 1 lone pair. So that means it's tetrahedral. And then it has 1 lone pair, so they're not the same. That means it is trigonal pyramidal. And it is definitely a polar molecule because you can identify the top and the bottom. All right, let's see. Next, 2 bonds, 2 lone pairs. Let's see here, look on here. 2 bonds, 2 lone pairs. We didn't draw it on this page, but have we drawn it? Yes, we have. Look, we drew it right here. So this is water. That might be a little bit tricky. Water has a total of 4 groups, so it's tetrahedral, and it's definitely a polar molecule. All right, next one. We're looking for a trigonal planar molecule that's not polar. That means we need 3 groups where they're all the same. So that's going to be SO3. Nope, SO3. No lone pairs. Shape. So these bonds, even if they are polar, because there is resonance, so they're going to be at an angle where they're going to cancel each other out. Next one, 2 bonds, 1 lone pair. So that's a total of 3 groups, so that's also trigonal planar. All right, let's find this one. So here, we're looking for AX2E1. Not on that page. There it is. NO2 minus 1. You can probably use process of elimination by this point. All right, so that means it has a shape of bent, and it is definitely a polar molecule. Carbon dioxide is here. It has two groups, no lone pairs, so its shape and its geometry are all the same. It's linear, and it's not a polar molecule.